Welcome to Education Beyond Borders Nano Knowledge Lectures. I am Kayla, your digital educator created by Dr. Iyer to help with his educational programs. Now, while I may be a digital creation, the educational material I will be sharing has been personally curated, reviewed and approved by Dr. Iyer. The molecules of life. As of 2025, there are 118 known elements in the universe. But only 94 elements occur naturally on Earth. Yet out of all these, only 4 elements, hydrogen, oxygen, nitrogen and carbon, comprise almost all life on planet Earth. These are the molecules of life, and they have certain unique features that determine why life evolved to use these as its building blocks. It is easy to understand organic and biological chemistry if we arrange the 4 molecules of life in order of the number of electrons that they need to complete the octet rule. The octet rule can be remembered by a simple limerick. 8 marbles in my outer shell make me whole, except helium and hydrogen that make do with 2. Put simply, every element requires 8 electrons in its outermost orbital shell to be maximally stable. The exceptions are helium and hydrogen. Helium has 2 electrons and is already stable at its ground state, which is why it is an inert gas. Hydrogen has only 1 electron and therefore can accept 1 other electron to reach the ground state. The number of electrons an element needs to reach its ground state of maximal stability is called its valence. Hydrogen has a valence of 1, oxygen is 2, nitrogen is 3, and carbon is 4. Another easy image to imprint this fact in your mind is what I call the molecular dating game, which I created to remember this. Hydrogen can partner with 1 other element, so I called hydrogen as monogamous, or the faithful one. Oxygen can partner with 2 at the same time, so I remembered it as bigamous. It likes to have a mistress on the side. Nitrogen with a valence of 3 was what I remembered as a cheater. It likes to bond with 3 at the same time, and carbon, with a valence of 4, was a player capable of forming bond with 4 other partner molecules at the same time. The arrangement of bonds in the following 3 compounds illustrate the principle of electron bond sharing in the outermost orbital shell to form stable compounds that satisfies the octet rule for all molecules. In the molecular structure of water, we see 2 hydrogen atoms, each sharing their single electron, with oxygen to form a stable octet for oxygen and a stable duplex for hydrogen, thus resulting in all partners achieving the maximal stable ground state. The same is seen with ammonia in the sharing of 3 outer electrons from 3 hydrogen atoms with a single nitrogen atom. While in the alkane compound methane, we can see how the capacity of a carbon atom to form 4 bonds allows for 4 hydrogen atoms to form a stable covalent structure of methane. Now, for convenience, we can represent these relationships as a stick diagram of lines representing these covalent bonds between alphabet letters representing the names of these atoms. It is important to note that water with its 2 hydrogen and 1 oxygen atom may be called HOH, or hydrogen hydroxide, though that is not what we commonly call it. Similarly, the amine group NH2 is derived from ammonia, and the methyl CH3 group OS derived from the alkane methane. This last term of alkane is important to remember since you will see it come up frequently in biological chemistry as alkyl groups, and the general formula for an alkane is CnH2n+2, where N is the number of carbon atoms present in that compound. An alkane is a type of organic molecule. Specifically, it is a saturated hydrocarbon made up of only carbon and hydrogen atoms linked by single covalent bonds. The term saturated implies that all the available valences of each carbon atom in that compound is linked by a single covalent bond. Alkanes have the general formula CnH2n+2 and are characterized by their lack of double or triple bonds. In the examples shown, methane, ethane, and propane are each 1, 2, or 3 carbon-saturated alkanes covalently linked with hydrogen and adjacent carbon atoms such that all valences are satisfied by single bonds. The portion of each alkane molecule encircled by the circle that excludes the last hydrogen atom in the chain is called an alkyl group. So we have methyl as the alkyl group for methane. ethyl as the alkyl group for ethane and propyl as the alkyl group for propane, and so on. Now, if the last hydrogen atom in the chain is replaced with a hydroxyl group, or OH group, then you would get an alcohol. So methane would give methanol with the formula CH3OH. Ethane would give ethanol with the formula C2H5OH, and so on. Alkanes, acyl groups, and alcohols are fundamental building blocks of biological chemistry, and these molecules form vital structures in all living creatures. This concludes the Nano Knowledge lecture of Education Beyond Borders on the fundamentals of the molecules of life. In the next Nano Knowledge lecture, I will briefly introduce you to the three-dimensional structure of carbon bonds, concepts of isomers, and what these facts imply in the area of molecular shapes, interactions, and functions. Happy knowledge learning!